Welcome to the Bentley Institute Quick Start training course in modeling bridge structures in RM Bridge Modeler. In the lectures of this course you will learn how to model bridge structures in RM Bridge Modeler. This is an introductory course, and in it we will show you the basics of modeling bridge structures based on axis and cross-section information. You will learn how to locate a structure with respect to the road alignment. And you will learn how to use cross-sections and segments for modeling the structure of a bridge and how to model realistic support conditions. At the end of this course, you should be able to model bridge structures based on axis, cross-section and segment definition. RM Bridge Modeler is a geometric preprocessor for modeling of bridge structures. The main components for the modeling are axis, cross-section and segment. Usually a bridge project is related to a road or rail project. Consequently, the alignment of such a project in RM Bridge Modeler is input as axis and defines the first direction of the structural model. The other two directions are defined by the so-called cross-section, whereas the input cross-section not only defines the cross-section of a beam, but also its position relative to the axis. And finally, the segment is the tool where all this information is put together to get the structural model. Understanding this general approach on modeling of bridge structures based on axis, cross-section and segment definition will enable you to model any type and shape of bridge structures. In the first lecture of our Bridge Quick Start course, you will learn how to start a new project and how to generate a straight axis. And later you will learn how to model a cross-section. Well, you can launch RM Bridge by double-clicking on the RM icon on your desktop. In the File toolbar, select Open RM Bridge Project. Use the project browser to select a convenient directory for your project. We have select Start a new project and press OK. In the Initialize Project dialog, in the General Options tab, we can select a design code check. Here we use the standard for demonstration purpose, and we can select a predefined material group. In the Project Information tab, we can input up to 2 lines, will be printed out on all your list files. Here we use RM Bridge Quick Start. Okay. With double click on Modeler, we open the Modeler tree. With the right mouse we press on Axis and select New Axis. In the New Axis dialog we can give a certain name for this axis. As we input a straight axis, we use here the predefined axis with a length of 100 meters. More general information of input and import of axis information are given in another learning path. The next step in modeling your bridge structure is to model a cross-section. In a first step, we will import a predefined cross-section from the catalog into our project. To create a new cross-section in the Modeler navigation tree, click with the right mouse button on cross-section, select New Cross-section. In the New Cross-section dialog, click on Import from Catalog. Within the catalog, select Standard, and in the standard we use the circle. We give a reasonable name, we call it Pier, and press Apply to import the cross-section into our project. And finally, you will learn how to model a general cross-section based on construction lines and cross-section elements. Furthermore, you will learn how to define cross-section points in a cross-section for later reference in modeling realistic support conditions. When starting a new cross-section, you will see two basic construction lines. The intersection of the two basic construction lines is the origin of the cross-section, and later, when generating the model, this will be the reference to the axis. All other construction lines are defined relative to existing construction lines, and they will keep the dependency information from the modeling. In a first step, you have to prepare all the construction lines which are necessary for the cross-section elements. The cross-section itself is then composed of cross-section elements. They are input based on intersection of construction lines. In this exercise, we will model a simple cross-section. Total width of the cross-section is 6 meter, and width of the bottom face is 2.4 meter. The total height is 1.2 meter, and the thickness of the cantilever plate varies between 20 and 30 centimeter. In the modeler navigation tree, click with the right mouse on cross-section and new cross-section. Give a reasonable name for this cross-section, main girder, and press OK. The two basic construction lines define the local coordinate system of the cross-section, and the intersection of these two construction lines represent the connection to the axis. In the modular navigation tree, click with the right mouse on cross-section and select New Cross-section. Give a reasonable name to the cross-section, let's call it main girder, and press OK. The two basic construction lines define the local coordinate system of the cross-section. The intersection of the two construction lines is the connection to the axis. In the first step, we will now generate all the 9 necessary construction lines, 6 vertical and 3 horizontal construction lines, which are necessary to define our cross-section elements. Starting with the outmost construction lines, we select here in the distance of the construction line, 3 meter to each side. Then we use here the parallel construction line icon to create the new construction lines. You will see here in this input field what is the required next action. So let's choose the vertical construction line as the reference line and click to the left side to generate the new one. Repeat this to the other side. Now we change the input here to 1.2 meter, which is the height of the cross section and half the width of the bottom plate. We again press here parallel construction line, use the horizontal one downward, and again we make parallel construction lines from the center to the left and from the center to the right. Then we change the input to 0.2 meter. We make parallel construction line from here to the left, from here to the right, and also from the top downward. And finally, for the variation of the cantilever plate, we input here 0.1 meter and make a parallel line from here to here. You can use the mouse wheel to zoom in and zoom out. To calibrate your view on the cross section. The next step is the input of our cross section elements. Therefore, we press here the line 4-point elements button, and now we have to select the 4 intersection points to generate our first element. We start here with this intersection. This is the second one, this is the third and the fourth. And we have generated our first element. Now we input the second line. And the third element. And finally the fourth element, and our cross section is finished. And finally we have to define geometry points for later reference for the real location of our bearings. They will be 20 centimeters from the edge of the bottom face. Therefore we input here another constant of 20 centimeters, and we make another parallel line to the middle of the bottom face. Now we create a new reference set. We use the drop down button of reference set for this. We give a reasonable name, let's call it connection points. It is of type connection points, and we press OK. We activate this reference set, and we use the input button for reference set. We click here on the intersection of these two construction lines and give a reasonable name to this connection point. Let's call it connection point in the middle. Press OK. On the left side we call the reference point connection point on the left side, and on the right side we call it connection point on the right side. With this cross section we can model our bridge.